Hello there. Let's solve some quadratics. First rule of solving quadratics is the quadratic formula is a point of last resort. For example, this first one up here, it's got an x squared. There are no x's in it. The b value is going to be 0. It's got constants. So when I'm trying to algebraically solve it, I only have to deal with the x squared. I don't have to deal simultaneously with an x squared and an x. So no quadratic formula necessary. Subtract the 1. Divide by 2. Square root both sides. Remember that it's going to be both the positive and the negative, and root 12 we can clean up, so get it in simplest radical form. Remember, you got to have both of them, both positive and negative, 2 square roots of 3. Okay, this next one over here. No quadratic formula necessary again. I have an a value, a b value, but the c value is equal to 0. So this one I can factor. Now we unzip it, zero product property. So remember, there are two cases. Either the left-hand side, the 3x is 0, or this one is 0, for the whole product to be equal to that 0, and you solve each of those. And my options are 0 and negative 3. Okay, this next one over here. Again, let's factor it, because the c value is equal to 0. And then we solve for each of those. The left-hand side is equal to 0, 0. And then the other one, that's a linear equation we have to solve, so we move the 5 over to the other side. It's positive 5, and divide by 2, and we get 5 halves. We could also write that as 0 and 2.5. Okay. Over here, it's not in the form that I need it in yet. I really want it to be in the form where it equals 0, so I'm going to subtract 14. Please, please, please remember to put in your equal zeros into these when you do them. Okay, you got an a value of 1, a b value of 5, a c value of negative 14. We could go to the quadratic formula, but in this one, actually, I could think of a combination that multiplies to negative 14 and adds to 5. And my winning combination for that is going to be positive 7 and negative 2. They multiply to negative 14, and they add up to 5. So that's how this thing's going to factor. So this one actually factors into this form here. First, x squared, outer negative 2x, inner 7x, that combines to 5x minus 14. And then from here I do the zero product property. So either x plus 7 is 0, or x minus 2 is 0, and the solutions for those are going to be negative 7 and positive 2. And you could also, once you get good at this, you can just pull that from here. Negative 7, positive 2. Alright, next one. What multiplies to 3 and adds to negative 6? Nothing. Okay, this one is a quadratic formula. Alright, so x equals negative b, negative negative makes it plus positive 6, plus minus square root. Negative 6 quantity squared is 36, minus 4 times a is 1, times c is 3, all over 2 times 1. Too far in that all over there. Oop. Clean up the inside. So I get 36 minus 12, which is 24. 24, we can get that in simplest radical form. Let's see here. 24 is 4 is the biggest perfect square that goes into it, so square root of 4 is a 2, and 24 over 4 is 6. And we got evens, so 6 over 2 is 3, 2 over 2 is 1, so I get 3 plus minus the square root of 6. Okay, and the next one's also pretty big. Well, quadratic formula, I guess. So x equals negative b, negative 13, plus or minus, it's at 13 squared minus 4 times a is 6 times b is negative 5, all over 2 times a is 6. Cleaning up the inside there, we get 169. Now I'm looking at the minus here and the negative over there, so that tells me that this is going to be 169 plus 6 times 5 is 30, and that times 4 is 120. and this is all over 12. Not looking all that nice. Alright, 169 plus 120 is 289. That over 12. And what does 289... Is that 17 squared? That's 17 squared. You can type that into your calculator to verify there that you don't get a big long string of decimals, but I get this, and don't leave it like that, but evaluate each of these. You want to get it into a reduced form, so do them separately. So if I'm adding, I wind up getting 4 over 12, which is a third. And if I'm subtracting, I get 13 minus 17 is negative 30 over 12, and that reduces, let's see, they're both even, so it's 15 over 6, and those are both divisible by 3, so it's negative 5 over 2. And then we can write our final answer. We want to get it in that nice form there. We could write it as negative 5 over 2. I went to the decimal, negative 2.5. This one over here, that 1/3, I'm not going to write that as 0.3 or 0.333 repeating. Please write it just as the fraction 1/3. These are rational numbers. Back here we had that root 6 one, so this actually implies that this problem here could have been solved without the use of the quadratic formula if we had been clever about how we factor, namely how we deal with this 6 out in front of all of that. And we'll see how to do that later with the RS method. Character and scholarship for life.